The invisible architects. How fungi built the world beneath our feet. What if the most powerful builders on Earth never used tools, never made a sound, and never showed themselves? They don't rise into the sky like skyscrapers. They don't carve mountains or dam rivers. Instead, they weave beneath your feet in the quiet darkness of the soil. Fungi are threading together the systems that make life possible. Forests, food, medicine, even the air you breathe depend on them. And the deeper you look, the stranger and more important they become. The first architects of land. Long before forests, before animals, before anything that looked remotely like our world, Earth was mostly barren rock. Then came fungi. Around 400 million years ago, towering structures called prototaxides rose from the landscape, giant fungal spires reaching up to 30 feet tall. Imagine a world where mushrooms, not trees, ruled the skyline. But fungi didn't just stand there looking dramatic. They made life on land possible. Early plants didn't have roots. They couldn't pull nutrients from soil that barely existed. Fungi stepped in, literally attaching to these primitive plants, acting as their root systems in exchange for sugars. This partnership allowed plants to spread across land, transforming Earth from a rocky wasteland into a green planet. Fungi didn't just join the ecosystem, they built it. The hidden network, nature's living internet. Today, fungi continue their quiet construction, just underground. Beneath forests lies a vast network of fungal threads called mycelium, connecting plant roots in a system so complex it's often compared to the internet. Through this network, trees share nutrients, plants send chemical warnings, entire ecosystems stay balanced. This relationship is called mycorrhiza, and it's more than just cooperation. It's a biological alliance. There are even two main types. Ectomycorrhizal fungi wrap around plant roots like a glove. Endomycorrhizal fungi go further, slipping inside plant cells. Inside those cells, something remarkable happens. The fungus grows tiny, tree-shaped structures called arbuscules, delicate branching forms that look like microscopic forests. These are not acts of invasion, but of connection. Intricate exchange points where nutrients and sugars flow in a constant living negotiation. A handshake turned into architecture. The underground economy. At first glance, this network seems generous. Trees helping trees, nutrients flowing freely. But look closer and it behaves less like a charity and more like a marketplace. Fungi are surprisingly selective. They can direct nutrients toward plants that provide more sugars and limit support to those that give less in return. In other words, they reward better trading partners. Beneath the forest floor, millions of microscopic transactions are happening every second. No coins, no contracts, just carbon, nitrogen, and the quiet logic of exchange. The great recyclers and the war on wood. If fungi disappeared tomorrow, the world wouldn't just look different, it would stop working. Fungi are the only organisms capable of breaking down lignin, the tough material that makes wood rigid. But they weren't always able to. During the Carboniferous period around 300 million years ago, trees grew and died, but nothing could fully decompose them. Vast forests collapsed into enormous piles of undecayed wood, slowly compressing over time into the coal deposits we mine today. Then fungi evolved a new ability, enzymes capable of digesting lignin. It was a turning point. The endless buildup of dead forests stopped. The carbon cycle resumed. The planet could breathe again. Fungi didn't just clean up the mess, they rewrote Earth's future. Intelligence without a brain. Here's where things get strange. Fungi don't have brains, no central command, no leader, and yet they solve problems. In one experiment, scientists placed food sources on a map of Tokyo representing subway stations. A slime mold grew a network connecting them, and the pattern it formed closely matched the efficiency of Tokyo's actual rail system. No planning, no blueprint, just growth. But what emerged wasn't random. It balanced distance, efficiency, and resilience in ways human engineers strive to achieve. It suggests something profound. Intelligence may not require a brain, only connection. From bread to breakthroughs. Fungi also shape human life in quieter, more delicious ways. That soft bread? Yeast. That sharp cheese? Carefully cultivated mold. That chocolate or coffee? Fermented with the help of fungi. They are masters of transformation, turning simple ingredients into complex flavors, and sometimes they change history. In 1928, a stray mold led to the discovery of penicillin, launching the age of antibiotics and saving millions of lives, all from an organism most people would throw away. The dark side, when fungi turn. But not all architects build. Some destroy. Certain fungi act as pathogens, reshaping ecosystems in devastating ways. The chytrid fungus, for example, is currently driving a global decline in amphibians, an ecological crisis unfolding quietly across continents. Others are more unsettling. The fungus Ophiocordyceps infects insects, taking control of their bodies and behavior, turning them into carriers that spread fungal spores. And then there is a quieter, more modern concern. Most fungi cannot survive above 30 to 35 degrees Celsius, which is why the human body's temperature acts as a natural defense. But as global temperatures rise, some fungi are adapting. Species like Candida auris have already crossed that threshold, emerging in hospitals, resistant to multiple treatments, capable of surviving in conditions that once kept fungi out. It's not science fiction, it's adaptation. Nature's cleanup crew and beyond. Yet fungi are not just destroyers or recyclers, they are also problem solvers. Certain species can break down oil, pesticides, and even plastic, a process known as mycoremediation. Even more astonishing, fungi have been found growing inside the ruins of Chernobyl. These organisms don't just survive radiation, they use it. Through a process sometimes called radiosynthesis, they rely on melanin, the same pigment that colors human skin, to convert gamma radiation into usable chemical energy. Much like plants use chlorophyll to turn sunlight into food, they don't just endure extreme environments, they feed on them. Fungi by the numbers. Estimated species 2.2 to 3.8 million. Named species only about 150,000. Largest organism, a fungus in Oregon spanning nearly 4 square miles, estimated to be between 2,400 and 8,000 years old, making it not just one of the largest, but one of the oldest living organisms on Earth. Age, over 1 billion years as a kingdom. A quiet power beneath everything. Fungi don't demand attention. They don't compete for the spotlight. But they are everywhere, holding systems together, connecting life, recycling death into possibility. We spend billions protecting animals we can see, tigers, whales, elephants, but the systems beneath them, the soil, the fungal networks, the invisible architecture of life, are often ignored. You can plant a forest, but without the fungi beneath it, that forest may never truly live. Final thought. The true architects of our world don't build with steel or stone. They build with threads, and they've been doing it long before we ever arrived, and will likely continue long after we're gone.
It's time to study new words in context. 1. Decompose. Definition: to break down something into smaller parts, especially after it dies or rots. Example: fallen leaves decompose and become part of the soil. 2. Undecayed. Definition: not broken down or not rotted yet. Example: the old tree remained undecayed for many years in the dry forest. 3. Enzymes. Definition: special substances in living things that help speed up chemical changes, like breaking down food. Example: enzymes in your stomach help break down the food you eat. 4. Slime. Definition: a thick, wet, and slippery substance. Example: the frog's skin was covered in slime to keep it moist. 5. Resilience. Definition: the ability to recover quickly from problems or difficult situations. Example: the plant showed resilience by growing again after the storm. 6. Pathogen. Definition: a tiny organism, like bacteria or fungi, that can cause disease. Example: the doctor warned that the pathogen could spread quickly. 7. Amphibian. Definition: a type of animal that can live both in water and on land, like frogs or salamanders. Example: a frog is an amphibian because it lives in water and on land. 8. Unsettling. Definition: making you feel nervous, uncomfortable, or slightly scared. Example: the strange noise at night was very unsettling. 9. Spores. Definition: very small cells made by fungi or plants that can grow into new organisms. Example: mushrooms release spores into the air to reproduce.
Comprehension questions. 1. What are fungi described as in the article? Answer: fungi are described as invisible architects that help build and support life on Earth. 2. What are mycelium networks? Answer: mycelium networks are underground threads of fungi that connect plants and help them share nutrients and information. 3. Why are fungi important for forests? Answer: fungi help trees get nutrients, share resources, and grow, so forests cannot survive without them. 4. What is mycorrhiza? Answer: mycorrhiza is a partnership between fungi and plant roots, where both help each other survive. 5. What are arbuscules? Answer: arbuscules are tiny, tree-like structures inside plant cells, where fungi and plants exchange nutrients. 6. How do fungi act like a marketplace underground? Answer: fungi give more nutrients to plants that provide more sugars, like a trading system. 7. What is lignin, and why is it important? Answer: lignin is a strong material in wood, and fungi are important because they can break it down. 8. What happened during the Carboniferous period? Answer: dead trees did not decompose, and over time they became coal because fungi could not break them down yet. 9. What did fungi change after they learned to break down lignin? Answer: they restarted the carbon cycle and stopped the buildup of dead forests. 10. What does the Tokyo subway experiment show about fungi? Answer: it shows that fungi can form efficient networks without a brain, like intelligent systems. 11. How are fungi useful in food production? Answer: fungi help make bread, cheese, chocolate, and drinks by changing ingredients into different forms. 12. Why is penicillin important? Answer: penicillin is a medicine discovered from fungi that has saved millions of lives. 13. What is an example of harmful fungi? Answer: the chytrid fungus harms amphibians, and Ophiocordyceps controls insects. 14. Why is Candida auris concerning? Answer: it can survive higher temperatures and cause infections in humans, especially in hospitals. 15. What is mycoremediation? Answer: mycoremediation is the use of fungi to clean pollution like oil, chemicals, or waste. 16. What is special about fungi found in Chernobyl? Answer: they can use radiation as energy through a process called radiosynthesis. 17. Why are fungi important for the future? Answer: they can help create new materials, clean pollution, and support sustainable living. 18. What is the main message of the article? Answer: fungi are essential and powerful organisms that quietly support life and shape the world.